angels come down, help with this parade. To hear your voice ring out, come on and shout it, let your song be heard. This is the time, this is the day that we've been waiting for. All the world stop to watch you shine.
Welcome to Revise with Mrs. C. We're going to have a look at calculating the mass of reactants that are required in order to make a certain volume or mass of products. In this question, it's telling you that a tube of toothpaste contains 1.2 grams of SnF2. So again, it's giving you the information you need to know. You want to calculate the mass of fluorine in this amount of toothpaste. So the first thing you want to do is go back to your periodic table and find your ARs, your atomic masses. So here we are. We've got fluorine up here at 19 and tin down here at 119. So I'm going to put those values down into my question. You would have this information given to you already in your question. If not, then it's as simple as looking at the top number on your periodic table. Okay, now I've got those numbers. All I need to do is write down my formula. So I'm going to draw a line down so I can see the difference between where I'm working. I need to find out the mass of fluorine. Now, if we wanted to find out the mass of fluorine, I have to look at how many times fluorine appears in the formula. And because of this little 2, I need to calculate 2 times fluorine. So I'm going to go 19 times 2. And that's a little bit I want to know about. In order to find out the big bit, it's the molecular mass of all of SnF2. If you don't know how to find the molecular mass or the relative formula mass, please do have a look at those clips that are also available on this channel. So Sn has 119 plus I want 2 lots of the fluorine in that. I'm going to put all of that in brackets. Once I've done that, I'm then going to multiply it by the value that I want to produce, which is the value I was given in the question. This looks all a little bit daunting, and I would strongly suggest that when you're calculating this, you do it in parts on your calculator so that you don't get into trouble. The only reason why I would say to write it out in full to start with is so that it's used as an instruction manual for you so you know what to do. So the first thing I'm going to do is multiply my little bit. So 19 times 2 equals, and let's have a look at that. Oops, sorry, it'd help if the calculator was on. 19 times 2, and our answer there is 38. I'm going to do that twice, as always, just to make sure I get the same value twice. And whatever I get twice is the value I write down. So that's 38 divided by 119 plus 2 lots of 19. So 119 plus 2 lots of 19, which I know is now 38, and that answer is 157. I'm going to do that again just to make sure that I'm getting the same value twice. This is an internal check that you need for all of your calculations. I've now got that. I put that in brackets and I multiply that by 1.2. At this stage, now you can do all of that in the calculator by using your brackets. So here we go. Bracket 38 divided by 157 end bracket times 1.2 equals, and my answer there is 0.29. I'm going to do that again just to make sure that I've got that value right. 38 divided by 157 equals times 1.2. Do you notice how I did it both ways? And look, oh, sorry, try that again. 38 divided by 157 equals, times that by 1.2 and equals. I didn't get the right number or the same number, so I'm going to do it now a third time. Bracket 38 divided by 157 end bracket times 1.2 equals, and again, let's have a look, and there's my 0.29, so I've gotten that value now twice. Do you see how it's really, really important that you make sure you get the same value on your calculator twice before you write down an answer? Otherwise, silly mistakes can happen. And if I had have written down, had done that just once, if I'd written down my first answer, yes, it would have been the right one. However, if I had have gotten the weird number that I got second and wrote that down, then I would have lost 2 marks. So let's put that answer down at 0.29. And it's asking me the mass, so I'm going back to my question. It asked me the mass, so because I'm looking for the mass of fluorine, then I need to put the units down at grams. 1 mark for your answer and 1 mark for your grams. Now it's time for you to have a go. Here are 2 questions for you to have a go at. Okay, you should have had enough time to calculate that now, so let's have a look at what the answer is. So normally in a question you would have already calculated the molecular mass of carbon dioxide, and they would have given you the AR of carbon and of oxygen. However, in this question I've not given them to you, so you need to calculate it yourself. So the first thing we're going to do is have a look at the periodic table. Here it is here. The atomic mass for carbon is 12 and the atomic mass for oxygen is 16. So let's just write that down. The AR of carbon is 12 and the oxygen AR is 16. So now that I've got that, I'm wanting to find out the mass of carbon, 12, that can go into 6 grams times 6 of carbon dioxide. So that's 1C plus 2 O's. If I was to calculate that, that's 12 divided by 12 plus bracket 2 times 16 end bracket equals, and we get 44. I'll do that again to make sure I get the same answer, and here it is. 12 plus bracket 16 times 2 end bracket equals, and if you see there, that's 44. So I'm going to put 44 down there, times that by 6. I'm going to do this again on the calculator, and that way I'm going to get to find out the mass of carbon in 6 grams of CO2. So I start with my bracket, 12 divided by 44 end bracket times 6 equals, and the answer there is 1.636. So I'll do it again, make sure I get the same answer twice. Bracket 12 divided by 44 end bracket times 6 equals, and there we've got the same answer again, so we're going to write that answer down. 1.6. I'm going to leave it at 1 decimal place because that 3 is 4 and under, so I don't have to change this, don't have to worry about it. And they're asking for mass, so the units are going to be G, so that would give you 2 marks. If we then go down to the mass of aluminium in 2 tonne of aluminium oxide, you don't need to worry about changing your tonnes, because normally if you do have to change anything, it's between it's between grams and kilograms, and normally in physics, in chemistry, they will say 2 tonne in 6 tonne or something along those lines. So the units will be the same, so don't worry about that. All right, we know that the AR of oxygen is 16 because we found that out just a moment ago, and the AR of aluminium we can find out straight from our periodic table. Here it is. There's aluminium and it's 27, so I'm going to write 27 down here. I want to find the mass of aluminium, so I'm putting aluminium up there, and I want to find it in 2 tonne of aluminium oxide. There are 2 aluminiums and there are 3 oxygens. So if we were to write that out with the actual numbers, that would be equal to 27 over 2 lots of 27 plus 16, or 3 lots of 16. Altogether, you need to multiply that by 2. So let's do it little bit by little bit because we don't want the calculator to have an issue. So if we look at that, I'm going to do my MR of aluminium oxide first. So I can go bracket 2 times 27 end bracket plus bracket 3 times 16, end bracket, equals. Let's have a look at that answer. It's 102, so we'll try that again, make sure that we've got that right. Bracket 2 times 27, end bracket, plus, open bracket, 3 times 16, end bracket, equals. And what have we got? 102. So we know that that for sure is going to be 102. And if it's not 102, then we've got that answer wrong twice. Okay, I'll just open up my paper here so I've got a little bit more room to work with. What I'm going to do now is my actual answer. So let's have a look at that. Bracket 27 divided by 102, end bracket, times 2, equals, and that gives me 0.529. Continuing, I'll do that again. I'll do it a different way. 27 divided by 102 equals, and then I times that by 2 equals, and I should be given the same answer. So that's 0.529. So if I put there 0.5294, an easy way to write that down, and let's say we're going to leave that at 1 decimal place, so I'm going to change it to 0.5, which would be your answer, 1 mark, and in order to get the second mark you need to put your units down, which is grams.